Hi everyone. I see most of you have joined us already, so I will start with a small thank you for joining us today in our webinar on how Gazpachos RTLS makes for smarter manufacturing. Today you will be meeting Daniel, who has 25 years experience in manufacturing. Oh, sorry, technical difficulties here. Apologize for this. There we go. Daniel, he has over 25 years of experience. One of his goals have been making manufacturing better by using digital technology. You will also be meeting Pontus Rosengren. He has been with us at Virtual since 2016, and his passion lies in lean principles. We also will meet Matthew Anderson from Sulzer, one of our customers. And he also has 25 years experience, but you will learn more about him shortly. Daniel will be explaining why Gazpachos RTLS is the future of manufacturing. Pontus will take you through the nitty and gritty of Gazpachos implementation. And Matthew will share his first-hand experience with Gazpachos RTLS. If you have any questions along the way, please write them in the chat and we will answer them at the end of the session. I will now hand over to you, Daniel.
Wonderful, Kimberly. Thank you for that introduction. Let me just share my screen here. And once again, thank you for joining us for this webinar. I hope the technology is with me here and that everyone can hear me loud and clear. Great to see so many of you joining us in this webinar. I think we should be over 30 people here today. A lot of known faces, but also a lot of unknown faces. My name is Daniel Wigren. I have been working here with the company for about since 2008, and today working as the head of sales and marketing for the company. Great. Let me just bring you back a bit on the history and some of the foundations and some of the thoughts that we had behind when we started developing this tool or this platform that we call Gazpacho today. Before I do that, I just want to become a bit philosophical, and let's all agree upon the fact that one of the greatest inventions that has ever happened was the introduction of the internet. Today, the internet has been out there, and we can more or less gather any type of data that we want in a very short period of time. I'd like to show this wheel where we can actually see how much information or how many transactions are happening on the internet in 1 minute. And when we look at some of these figures, we can sort of like think in terms on how much data we're actually storing. In all of the figures that we see here are actually transactions, and this is done in social medias or different types of social media companies that are evolving, and the main reason why they are evolving is due to the fact that we have the internet. As I mentioned before, all of these transactions, it's about sharing information, it's about storing information or data in some kind of shape, and actually working with that information to spread information more or less. With that said, I just want to take that information, and then if we connect it to where we are working on a daily basis, in other words, in the manufacturing industry, we should think in terms, how are we using the internet, or how are we enabling the fact that we can gather more data, store more data, but also analyze more data. If we'll go back a couple of years, when we started with the development of this platform, we were actually thinking in terms of using it as a tool to collect data. in some of the transformation projects that we were involved in with different types of customers. But there were some challenges that we saw on the market back then, and some of these challenges are still very, very relevant today in today's market, especially within the manufacturing industry. One of the challenges that we started looking at was, what we call invisibility of assets. I mean, to be honest with ourselves, when we go down on the shop floor, yes, we can see where we have assets, and assets, by assets, I mean, anything that we can more or less see on the shop floor. I mean, it could be operators, it could be forklifts, it could be tools, it could be jigs, it could be fixtures, it could be pallets or any type of material handling equipment, and so on and so on. There is a tendency that these assets are invisible unless we actually go down on the shop floor. In other words, we don't know where they are, or rather, we know where they are at a certain point of time, but we don't know where they are in real time. Another challenge that we tried to approach was the lack of standardized work processes, or rather, maybe not so much lack of standardized work processes. I mean, in many cases, we have our standards documented. The difficulties that we have within the manufacturing industry, I would say, and this is on a general basis, and some might be better than others, but it's actually seeing and trusting in that we are following our standardized work processes. In other words, we have them documented somewhere, but whether or not we're following them and working according to the standards, that we don't know. Another challenge that we're trying to approach is, coming to purchasing and sourcing. I mean, when do we need to buy stuff? And with stuff, I mean things like jigs, fixtures, tools, and how many have we actually bought? I mean, in many cases, there's an invisibility in actually seeing what do we actually have on the shop floor. When I mean lost assets, yes, some of you might think that, wait a second, we're not losing assets on our shop floor, but in some cases we are actually losing assets on the shop floor. And by assets in this case, I mean material, or I mean equipment. So when we started developing this solution, an important factor was also the fact that the terms of traceability. I mean, we want to see where have our assets been and where are they heading. And we want to store that data to be able to analyze the consequences of where they have been and where they're going. And last, but for sure not least, when it comes to safety and ergonomics, unfortunately, there are a lot of accidents that still happen on the manufacturing shop floor. A lot of the accidents are accidents that are caused by, for example, forklifts, or they're caused by any type of transportation vehicle on the shop floor. I mean, I believe that anything that we can do to actually at least try to visualize the risks that we have on the shop floor, and in terms of minimizing these risks, is work that is very much appreciated for most manufacturing companies. I'm sure that all of you are aware of the fact that we're living in a very interesting era right now. I'm not much for buzzwords, but there are a lot of buzzwords that are being circulated on the market today when it comes to the manufacturing industry. If we think in terms of the digital twins or virtual twins, or I'm not going to say that Industry 4.0 or even Industry 5.0 are buzzwords, but it's more of a methodology or a toolkit, if we put it that way. But I just want to bring up one fact that I mean, if you're sitting in a manufacturing company today and you're talking in terms of, yes, we want to take the next step when it comes to transformation, digital transformation. We are talking in terms of digital twin or virtual twins or Industry 4.0. I just want to really push the fact that when we are talking about location-based tracking systems, that is part of what we see as some kind of a digital twin or virtual twin area. In many times, yes, we want to be able to see our shop floor and we want to be able to categorize our shop floor. But in many cases, we're actually forgetting the fact that we need to be able to see how things are moving on the shop floor in real time. Once we've gotten to that point, then we can actually start talking in terms of digital twins. I mean, a digital twin is not just a static representation of your shop floor. It is some kind of you have to get the dynamics in there. If the dynamics are not in there, we're not talking the real digital twin. I think also one of there was a statement made by a customer of ours that was very early supporting the development of this platform. It's the name of the company is Scania. They're part of the Volkswagen Group, and one of their basis, one of their statements that they made earlier was the fact that anything that we can do on the shop floor that is based on taking decisions based on facts is good. In other words, on the shop floor, when we take decision, we like facts. If we don't have facts, then we have to start going to emotions, and emotions are not as good as facts. So Scania once said that Gazpachos or this type of tool has enabled us to take go from emotion-driven decisions on the shop floor to fact-based decisions. And if you are working on the manufacturing shop floor, whether it be running operations or not, I mean, facts is the key. Right. So just some takeaways from my side before I hand over to my colleague Pontus, where I really want to push on 6 different topics here that please do whatever you want with them, but please reflect on these topics and take them with you to your own organization. Bottom line, everything has to do with improving the shop floor. Yeah? So ask yourself on a daily basis, on a weekly basis, and your workforce what you can actually do in small steps to improve the everyday operations. If you have concerns or questions that are related to, invisibility of assets or safety, ask yourself what you're actually doing on a daily basis to improve the situation. That's the first one. The second one, let's all agree on the fact that if we don't have data, or if we're not collecting data, we cannot analyze data. And analyzing data is sort of the foundation for improvements. If we have data, we can analyze them, we can take decisions based on facts, and we don't have to go to the emotion-based decisions. So no data, no analytics, no improvements. Sounds kind of harsh, but there are some facts behind it. When it comes to technology and what you'll see the rest of this webinar, I mean, there are some very interesting things here, but it all comes down to, start simple. Things, of course, depending on which company you're coming from or where you're working, you always have to have the thoughts of being able to scale up in the back of your head. But start simple. The recommendation is look at where the problems are and try to do something to solve those problems in a small step initially. The fourth one, no transformation is going to happen if you don't find the ambassadors that are working with the transformation projects. So like always, I think it's important to look in your organization or in your team, find the digital ambassadors or find the ambassadors and sort of give them the opportunity to excel. So that's an organizational aspect of it. The fifth point, if we look at the market today and all the technologies out there, there are very, very few problems that theoretically could not be solved by some type of technology. The message that I'm trying to send here is that many times when we have difficulties and we're trying to solve them, if we think that technology could be an enabler, which it can in many cases, but let's not forget that there's so much more than technology. In other words, we need the organization behind it. But today there's so much technology out there. So in many cases, the actual technology side of it is not the problem. What we see based on the experience that we have is that it's more the willingness to transform or the willingness to change and actually finding the organization that can handle the transformation. All right. Final takeaway from my side before I hand over is that let's start thinking in terms that what if? I mean, what if we were able to see how things are moving on the shop floor in real time? Just imagine the things that could actually be done. With that said, I'm going to hand over to my colleague Pontus. We'll take questions, etc. at the end. Thank you.
Thank you, Daniel. So I'm here to talk a little bit about RTLS implementation and integration, but more so also to talk a little bit more about the different values of tracking per se, like what can you do with it, so we can go down to the nitty-gritty details. So one of the things that you can keep is to keep track of tools. So in what way will that bring us value then? So tools, what are tools if we break that down then? So we have forklift can be a tool. We can have power tools, fixtures, quality tools, welding equipment, different kind of racks that we need inside our factory. And knowing where these are and making sure that they are in the right location at the right time will definitely give us more information about how we're using our tools. So we can see that, for example, our average utilization grade on our forklift fleet is 37%. So, and still, we get lots of inquiries from the manufacturing floor that we want to buy more forklifts, for example. Maybe we want to check about quality tools. We want to know where have they been used, at what different stations. We can also check, for example, if things have been dropped and falling down to the floor. So we know that if we need to recalibrate things. We can keep track of kits and orders, both in-house in our own facility and also at our suppliers. So meaning that we can link up with the ERP data. And ERP data, usually we put in our routing information and our boom list. So if we would track a part going through our factory, we can see that is it in the right place according to the routing from the ERP system. How long time does it spend in this routing physical area? And we can also get different alarms if they are not in the right area, and also if things are not moving along. So we can get routing times and make sure that things are in the correct place. And we can also use this to feed data to upstream processes, meaning that we can tell them that we're going to be late because this one hasn't left the process yet. We can also get notifications if things don't leave our sub-suppliers at the right time. So getting data sooner can help us to react quicker. We can know that if different assets, like I said before, like when it comes to quality tooling has been dropped on the ground, so that we need to send them for recalibration. We can also know that if different things like items in the factory have been dropped down, so that we know that we need to recheck the quality of this part because it has had a sudden acceleration and hit the ground. We can make sure that we're charging assets during times when it's more beneficial to us. And we can connect it to unknown system, meaning that we can call for help, either for personnel that is in places where maybe no one else is looking at them. So if they're falling down or something is happening, we can send out a distress signal. Or we can also send an unknown signal with the coordinates of where we are right now. We can send it to different people within the organization, either if it's a health and safety concern, or if it's something that happened that we need a quality technician or a maintenance technician, for example. We can connect it if we're working with SMED. So we're working with a single minute exchange of die to make sure that we have the shortest possible setup times for our machines and our production lines. So each time we walk out during a setup from the area around the line, that means that we haven't planned our process good enough. So when we're doing a setup of a machine, we need to make sure that we bring all the equipment when the machine has stopped, so we can get it up and running as soon as possible, so we can start to earn money from it again. And most people, they earn a lot of money with SMED when they're doing the projects and can see that they can cut setup times with 50% or more. It's quite common. But what happens is usually that after a few weeks, things go back into the old routine. But by using tracking combined with SMED methodology, we can keep sure that we're always trying to follow what we have been planning, and that we can keep track of the times it actually takes for us to do the changeovers. So getting additional data. So we can connect to ERP systems to get information about orders. We can connect to MES systems to get information about changing. We can connect to tool calibration systems to see if things are how they're feeling. So Gazpachos is a hardware agnostic site. So this means that we do not care where the tracking signals comes from. We care about the customer's value that you want to get out of it. So depending on what you want to track and what kind of accuracy you want to track, there is different technologies that will suit your user case. So if you need to track finger movements in an assembly, for example, that is totally possible to do. And if you need to just keep in how we need to know roughly where things are, there is also other different technologies that suits better for that. So we can track everything from our supplier through their transportation, when it comes into our own storage and warehouse, or when it's sitting on the yard outside our factory, so that we're saving time from going around looking for items. We can keep track of it when we're transporting it from storage into production or from sub-suppliers into production. We can track it inside our production facilities so that we're knowing that things are moving in the right time. And if things are not moving, we can also get automatic alerts that something is not correct. We can use GPS to send it out when we're sending to distribution centers, and using RFID to know that it has arrived, for example. So the world of location intelligence. So it can help us keep track, like I said before, of things that we're having in our yard. It can keep track of where things are moving around in trucks. We can keep track of our workers. Are they okay? Are they in zones that are okay? We can make sure that when we're using forklifts together with this, maybe we can reduce the number of time it takes to scan things. Because if we're keeping track of what we're having on our forklifts and where the forklift is at all times, and when we're dropping things off, then there's no need to get out of the forklift and scan things. So we get shorter times when it comes to handling goods. We can have auto ID as things are moving through different processes. And we can have assembly tool control, making sure that we're bringing out the right tools to the right assembly process. And we can know that when do we need to replenish materials. So this can be a true help to move towards paperless manufacturing. And I would now like to leave over to Matthew, our customer from Sulzer.
Thank you, Pontus. Good day, everybody. Can everyone hear me okay? Okay, I'm just going to share my screen and begin. Thank you. So good day. Thank you for joining, everybody. I'm Matt Anderson. I work for an industrial company called Sulzer, where I'm responsible for our smart manufacturing initiatives that contribute to our continuous improvement, such as the one that we're talking about today that we've done with virtual manufacturing. First of all, I want to tell you a little bit about Sulzer. So Sulzer is a global leader in fluid engineering and chemical process applications. The company is known for pumping solutions, equipment for thermal separation technologies, and services of rotating equipment. Sorts of products are typically used in applications in water, oil and gas, power, and chemical industries. A very important aspect for us, for our solutions, is contributing towards helping our customers lower their carbon emissions, enhancing energy efficiency, and reduction of waste, which is a common theme when you're looking at manufacturing systems. Now, as part of our ongoing operational excellence efforts, Sulzer perform continuous improvement of our production approaches on a day-to-day basis. One of the most important areas is efficiently tracking the movement of components within our operations. Now, with some analysis that we undertook, we found that we could recover around maybe 100 hours per week for each facility, which is a significant amount. And in doing so, reduce lean waste of unnecessary material transport, unnecessary work and motion, such as searching for materials, and waiting. So the need here really was quite clear to us. We required a system that could provide accurate real-time location data to improve our workflows. Without this, valuable time is lost as employees search for items, leading to delays, decreased productivity, and really an opportunity delay in harnessing technology to create a seamless and cost-effective material tracking system. Now, a little bit about how it works. First of all, partnering with virtual manufacturing. Sulzer embarked on a journey to find the right technological solution. Now, Sulzer and Virtual have a relationship that have evolved over many years, covering a variety of different manufacturing solutions, such as this one. Quite positive here is that Virtual are very much a hardware agnostic company. So when they're able to evaluate the various options for our real-time location system needs that met the criteria for, in this case, accuracy and cost effectiveness. So importantly, also, we need a solution that was scaled to our facilities worldwide and integrate into our current processes and our existing systems. Now, here you can see my very simplified sketch of the solution. We attach Bluetooth low energy transmitters, so small wireless devices, to materials and key assets in and outside of our factories. These broadcasts are picked up by locators, which are devices placed throughout the whole environment. They receive the Bluetooth low energy signals from transmitters and use advanced algorithms to calculate the precise location of materials in real time. Now, this data is joined in Virtual's Gazpachos solution with our own ERP information, allowing us to track materials by production order or material number when they're needed for various production tasks. The solution not only had to integrate with our current systems like SAP, but also had to be embraced by our teams as well. So that's quite an important point we had there. Moving on. So what were the benefits that we met during this project? Some immediate benefits. First and foremost, with our real-time location systems, you can monitor the exact location and movement of assets and materials within the facility, ensuring that everything is where it should be when it should be there. The next thing to highlight really that we found was the process efficiency improved significantly. With RTLS, you can quickly identify bottlenecks and inefficiencies in the production process, allowing for prompt optimization and resource allocation, and ultimately reducing downtime, improving throughput, which is one of the most fundamental areas that you see when you're looking at factory improvements, such as the theory of constraint, essentially, identifying and optimizing bottlenecks, managing the flow to reduce your work in progress outlay. Furthermore, the data was collected by our RTLS system. It is quite invaluable for analysis. You can analyze this data to identify trends and patterns and areas for improvement in manufacturing operations, leading to continuous process enhancement. And then finally, last but definitely not least, is the cost reduction, which is a significant advantage. By minimizing the downtime, by reducing the need for manual tracking and optimizing resource usage, we achieve substantial cost savings. Now, a bit about where we'd maybe like to play next. What are the possible next steps? I mentioned one of the key considerations here was scalability. So virtual manufacturing's Gazpachos solution allows modularity. It has this multi-service architecture, which is good because it allows you to connect to different things and trial different things. Also, it allows you connectivity to different systems, which allows deeper analysis of all the data you can gather together. And that's really where the value starts to grow when you start connecting this into other systems. So looking at some of the possible next steps, the first one I mentioned here is common component bottleneck identification. So going beyond the typical spaghetti diagram that you see for the overall material flow, one of our considerations is analysis of which components commonly cause the bottlenecks. So if you can imagine all the different components we manufacture, they come together at a point, at a packaged solution. The aim would be to pinpoint specific components that frequently impede flow production and then put together a plan to mitigate this. Second thing to mention is our experts are also working on a digital and-on system, which Pontus mentioned earlier, based on our existing RTLS system we have implemented. So in this case, machine operators would wear Bluetooth low energy badges, enabling them to call for help instantly with a press of a button, and the system would efficiently route that assistance based on their momentary location, allowing the right help at the right time and reducing operational downtime. And then thirdly, I think another interesting area we're working on is 3D scanning of our areas, similar to photo scanning by Google Earth or similar, and then augmenting it with a 3D CAD model of the environment, of the assets. Couple that with a material flow, and then other sources of data. This allows a degree of simulation of our shop floor footprint, allowing us to leverage our factories as an operational asset. Okay, with that, I will now seamlessly hand back to Kimberly.
Thank you, Matthew, and thank you everybody for joining us. We do have a couple of questions. I don't know whether Daniel or Pontus would like to answer this one, but what would be the average setup time if you decide to implement Gazpacho?
Yeah, I can take this one. So of course it depends totally on the size of the area and what you want to track. But usually after taking the decision to buy, and if the hardware is available, then we're talking just about to set up and commission the hardware is, I would say, around a week. And to set up, so we will build Gazpacho on a private cloud for the customer, so it will be inside the security network of the customer. So depending on what the requirements is on the security, it might take different times, but in average also around 2 to 3 weeks to set it up fully in the private cloud as well. So I would say in total a month, but hardware can be sometimes with today's material constraints, a little bit longer lead time, unfortunately, but yeah. So I would say about a month to answer that question.
Okay, thank you. Matthew, what made you choose Gazpacho?
So I kind of touched on it in the presentation, really. We've worked together for a number of years now, not just on these sort of engagements, but other as well. Virtual, first of all, very, very familiar with manufacturing problems, really. It's not just like a technical company and we tell them what to do. They come with proposed solutions to our problems, which I think is invaluable. Second, the Gazpacho application itself is very flexible. We can tie it into lots of different systems, and it allows, with this connectivity, to build stepwise a solution for our digital factories.
Thank you. I do have a personal question here at the end that I think most of us maybe are wondering about, but why is it called Gazpacho?
So it's named after the customer that bought the development of this software, and they choose to name it this basically. So I think that's the short answer to that one.
Perfect. Well, thank you all. We really appreciated you joining us today. We will send out a recording. If you have anybody in your offices that you think should listen or hear this, share it with them, and maybe we will see you in the future. Thank you.
Thank you.
Thank you, everyone.